So welcome to everyone watching this video. My name is Rohan Vashish, and in my previous video, somebody commented that how can we implement graphics in Zig programming language without using any other external libraries. Well, this is pretty much possible and we would be implementing this today. So smash the thumbs up button, also subscribe to the channel. Let's get started. So now I would tell you what is the PPM image format, portable pixmap. It is also called that. Okay. So what is PPM file? It is just a kind of an image file. Okay. Like we have a .png image for PNG images, right? .jpeg. Then we have .webp. We have different kinds of pictures, right? PNG, JPEG, and all of that. In the very same way, we have another format, PPM. So the extension would be .ppm. Now, portable pixmap format is, like its name. The speciality about this is that when like in PNG images, the image, if you will open it into Notepad, for example, you would see random characters. That's because it is binary format. Like most of the image formats are binary. But the speciality about PPM is that you can have it in two or actually more than two formats. Like we have ASCII format. So ASCII is something that which we can read. Okay. Binary is something which computers can read very well. So those are the two formats available for this PPM image. So for the starting, for the beginning, I would be using the ASCII format, P3 format of the image. I would show you how all of these formats are, like we change the format and how we do all of that. That I will show you on this slide. So what are the contents of the image file? Okay. Uh, Obviously there are two types of contents, right? One is like which you see on the screen, like like I am able to see this image right here. But what is the computer able to see, or what is inside the the file itself? That is this which is written here. P3, 42, 255, and all of this. What is this? Let me explain to you. If you will open an ASCII readable PPM image file, you would see this P3 at top. P3 tells that you can read the contents of the image file, like text only. But if it is P6, you won't be able to read it because that's binary. You like computers can read it, not humans. Now we have this 4.2. What is this? This is something that tells the reader that it is 4 pixels wide and 2 pixels height. So the width is of 4 pixels, the height is of 2 pixels. So you can see this image right here: red, green, blue, yellow, white, light gray, dark gray, and black. So this image right here is of 4 pixel width, 2 pixel height. Okay, you can see this right here. Okay, 255 is the like the third line in the header file, like inside the ppm file. So what is 255? 255 is basically it tells the range of colors. So it would be from 0, which is black, to 255, which is white, or that's the maximum value that the values of individual R, G, and B can approach. So from 0 to 255, that is the color range. Now, this part is known as header of the file. This is the header. Okay, like these three lines which you can see right here are the headers. First will tell it is an ASCII format. 4.2 will tell its width is 4 pixels, height is 2 pixels. 255 tells the maximum value of individual RGB values. Okay, now when I will do okay, so now let me explain you the body, like the content of the file. 25500. What is this? These are RGB values. R means red, G means green, B means blue. So 255 is red. If I will keep R as 255, G as 0, and B as 0, it will be a pure red pixel, as you can see here. This is full red pixel. 0 to 55 0 is green because G value, the green value is maximum. B blue, we have this maximum. When we have red and green both as maximum, we will get a yellow color pixel and so on, right? When we have, so now for initializing our Zig project, I would be running Zig init, Zig init. Now all of these files would be generated. So let's get started. I would be removing the default things. Now we'll do const std, we'll be able to add the import std. Then the first thing that we should start with is the public function main, and this returns void, and exclamation mark is for that we return an error. Okay, like this function can return an error. Now from here what we need to do is we would be printing to the std out. Okay, like there are two kinds of outputs. One is std error and another one is std out. So like when we print something onto the terminal, so there are two modes. I would be choosing the second mode, that is the std out. For that I would do const log, for example, or I would say outprint will be equal to std dot its io dot get std out dot writer. So this will be our output outprint, and I would be declaring this inside the main function because we are calling a function for that. And then outprint dot print. So now I could print hello world. This would take no other parameters and I would be printing this. So just for checking if everything is working or not, let's just run zig build run, and I think this should work. Okay, so there is some error. Okay, so try catch. Now obviously whenever you are using this outprint, this print function would return an error. So because it is returning an error, we should put a try in front of it so that it actually prints it out. So you can see the hello world is getting printed onto our terminal. So why am I printing it to the std out? The reason is that if I will run this like zig build run, and I would put a greater than sign in front of it and also add the output image file. So for example, out.ppm. So you can see this out.ppm will have hello world inside of it. Obviously, we don't need to put hello world inside of it. We would be printing different stuff. So the very first thing is the P3, as you remember, P3. Then a new line, and after that, we had the width and the height, right? So let's just choose a square image, 10 width and 10 height, and then in a new line 255 would be the maximum limit for the image, right? Now I would be adding the body content. So for now what we are going to do is we would be generating an image that would have random colors. That's it. Okay, random colors. If you want a part 2, just let me know in the comment section below, and also let me know if you want a shout out or not. Okay, so now I would be giving shout out on this channel, so just let me know that in the comments below. So for the so here we have the ppm header. Okay, like AI also works sometimes, it just adds the comments over it. Very good. Now the next thing which we need to do is for, so 0 dot dot 10, I would have the value of I, or instead of random, let's just do something, like let's just see what we can do. So for 0 dot dot 10, I would be having the value of J, and then we can get random values, right? So just for generating a random image that would have, like different kinds of pixels, nothing special. Okay, like just different pixels. For that we would need some random library. So inside the standard library we have something known as crypto, so we can use crypto for that. So const rand will be equal to std dot crypto dot random. So that's the thing. And we can use this random inside of this. So const random underscore number, random underscore value will be equal to rand dot int range at most. Okay, at most we can put. Then it needs the comp time t value, that's u8, and the at least will be 10, that's 0, and at most will be 255. 0 and 255, that would be the range. Now we have the random value. So let's just print the random value out there. Okay, so I can just use this line, that's also fine. And we do not really require the I and j values at this point. So I think so the program is ready, and let's just run this. So, okay, it has generated the output dot ppm image, and I think this should work pretty well. So let's just open this with, okay, so uh, reveal in Finder, and I would be opening this with GIMP. So here you can see we have this random pixelated image, like it has just, like these random values. What we can do is we can compress this stuff together. Like I can cut this, I can cut this out, and then instead of this random value, paste this, paste that, and paste that again. So let's just check that what we can observe. So I think so we need to reload or something. Uh, let's just reopen the file, open with GIMP. So let's just see what we can, what kind of image do we get. Okay. So now you can see this random noise getting generated. Like, like these are all the random colors that we are able to see. Obviously, we can make something more creative, right? Like we could add a new gradient, we could add more and more stuff to this. But for now, I think for this video, it's enough. Just let me know in the next video if you want more, then I would surely make it. So thank you guys for watching the video. Be sure to smash the thumbs up and also subscribe to the channel for more such content.